Right, now the next questions in electric potential and potential energy. 2 points S and T are located around a point charge of a positive 5.4 nanocoulomb as shown in the figure below. Okay, yeah, so we have S and T here. This should be the, so better you write down the information here. Okay, why not? Yeah, so this is a positive 5.4 nanocoulomb. Okay, so easy for you to get the information later. Calculate the electric potential difference between points S and T. Okay, so the question asks for potential difference between S and T. What is the difference between potential and potential difference? Yeah, potential and potential difference. Yeah, as you can see here, potential, like this one, Vs, this is called potential. Delta V is called the potential difference. You see that? Potential difference. So what's the difference between these two? Potential means potential at only one point. You only refer to one point. Yeah, potential at one point. Potential difference means it refers to 2 points. The difference in potential between 2 points. Yeah, potential difference between S and T got 2 points. So what's the difference in potential between Vs and Vt? Vs and Vt. What's the difference in their potential? Then that's why you need to use Vs minus Vt to find the potential difference. That is the delta V. The potential is only for 1 point. Potential difference is the difference between 2 points. Okay? So the question asks for potential difference between S and T. So which is this one is about delta V. If between S and T, that means you want between delta VST. Yeah. Potential difference between S and T, then we put ST. Yeah, S and T, ST. So delta VST. So delta VST is actually use Vs minus Vt. Yeah, just follow the sequence. ST means S minus T. Understand? Delta VST means S minus T. Yeah, just follow ST, ST. Okay? Now, if you want to find the delta V, we need to find the potential at S and also potential at T. So how? Let's calculate. So potential is KQ over R. So at S, it has potential. At T also has its own potential. So maybe I can write like that. Here, S, we have potential Vs. T, we have potential Vt. So let's calculate. Yeah. Both potential is contributed by the same point charge, by the same point charge Q. Yeah. Why S and T has potential? Because due to the same charge. Yeah, which give out the electric field. Okay. So let's calculate. Okay, let's calculate. So Vs is KQ. K is 9. Excuse me. 9 exponent 9, and the Q is you see, that's why I write the information at the diagram. Easy for me to plug in the information directly from the diagram. I don't need to look up to the question anymore. Okay, so this Q is 5.4. 5.4. Remember, nanocoulomb. Nano is -9. -9. Change to SI unit. So over R. What is the R? Distance R. Rs is from S to the point charge, which is 6 cm. 6 cm. So it's divided by 100 is 0.06 meter. Do you have square? Do you have square? No. Yeah. Scalar quantity. The R do not have square. Yeah. Remember, this is a scalar quantity. So scalar quantity, the R no square. Okay, that's good. So now let's calculate Vs. What's the Vs? Vs is actually 810 volt. 810 volt. That's good. Now how about Vt? So VT is VT is 9. Excuse me, happen now. VT is 9 exponent 9. So what's the charge? The charge is yeah. So the same charge also 5.4. Positive point charge. So it's 5.4. Negative 9. Negative 9. So divided by the distance. How far is it from How far is VT to the point charge? Don't put 8 cm. 8 cm is T to S, not to the point charge. So RT is actually this one. Maybe I should write it out. Just now this one is RS, isn't it? This is RS. 6 cm is RS. And RT is from here to here. This is RT. What is RT? How far is it? This right angle triangle, Pythagoras theorem. I got it. I got this RT is 10 cm. So simple, isn't it? 10 cm. So my distance is actually 0. Divide by 100. So 0.1 meter. 0.1 meter. So what is it? What is the value? It is positive, positive 486 volt. Okay, both are positive potential. Okay, both are positive potential because the point charge is positive. Okay, point charge is positive. If you have a negative point charge, you will have negative potential. The negative sign is a must. The charge. The charge you must have if the charge has negative sign, you must substitute the negative sign. Okay, but luckily this charge is a positive point charge. It's a positive point charge. That's why your potential is also positive. Okay, never mind. Now find the potential difference. I've already got the potential for each point, so now is to find the potential difference between the 2 points. Okay, so just minus out. Just minus out. Delta VST is the VS minus VT. Okay, VS minus VT. Just look at because the sequence is S and T, so better we write as delta VS T. Better we write as delta VS T. Oh, excuse me. So the because it's S and T, so that's why we write as delta VST. Just follow the sequence lah. Between S and T, then we put between S and T, so is VST. If between T and S, we write as delta VTS. Okay, but actually the word between, never mind. Between actually can be either way. But it's better that in default, the answer scheme is if the sequence is between S and T, then we write VST. If between T and S, we write delta V ES. Because in default, the answer scheme tend to be like that. So the answer scheme tend to be like that. So if between S and T, we just use the sequence delta V ST. Just follow the sequence S and T, delta V ST. If between T and S, just put delta V TS. Okay, follow the default one. So, okay, so delta VST is VS minus VT. Take the difference. So let's minus out, and let's see what's the value. Okay, VS is 810 volt, and then minus out the VT, which is 486 volt. So in the end, what do you get? In the end, I got 324 volt. 324 volt. Okay, that's the difference in potential between the 2 point S and T. Okay, 334 volt. Now, second questions. What is the work done in bringing the charge of negative 1.5 nanocoulomb from point T to point S? Okay, now in bringing this charge is moving, isn't it? This charge which is moving is actually the test charge. The test charge. Normally, test charge is the one who move around. You know, test charge is the one who moving around. Okay, test charge normally move around. For point charge don't move. This is the, you know, I just want to show you. This one is the point charge that provides the electric field and provides the potential for all the neighboring area. The point charge, you know, this is the point charge. Point charge is the one who provide everything, provide the electric field, provide the potential for all the neighborhood, for all the neighboring area. But the test charge is the one that moving around, you know, moving around. This test charge is inside the electric field provided by the point charge. You understand? Now, okay, this test charge, where is it moving? The test charge is moving from T to S. The test charge is moving from T to S. So, yeah, it's moving from T to S. Okay. So I want to wrap off this RT and RS. Now it's become like disturbing already. Yeah, I don't want this RS and RT anymore. Okay, because I already done the question A. Now, yeah. Now I want to do question B. Okay, this test charge is moving from T to S. T to S. So that means our T is initial. You know, let's write here. T is initial. S is final. Yeah, right again over there. T is the initial. S is the final. Understand? Okay. T is the initial. S is the final point. That means I'm moving the test charge from T to S. From T to S. So this test charge is moving around. It's a negative test charge. Wow, it's a negative test charge. Be careful. So this test charge is a negative test charge. Yeah, negative test charge. How should I write negative test charge? Is it obvious enough? Negative test charge. This is the Q naught. This is the Q naught, which is a negative test charge. Okay, I move the negative test charge from T to S. So the question asks for find the work done in doing so. Find the work done to move this test charge from T to S. That means I want to find the work done. I want to find the work done from T to S. To move the test charge from T to S. So about the sequence TS or ST, how do you do? Look at the from what point to what point. This one, he says work done from where? From T, isn't it? So work done from T to S. It's like that. WTS. Work done TS means work done from T to S. Yeah, work done from T to S. Understand? Work done from T to S. Work done from T to S. Work done from T to S means work done TS. If work done from S to T, what about work done from S to T? Work done from S to T, then you write as work done as T. Understand that? If the question asks work done from S to T, then you write as work done as T. Work done as T. Okay? Now, this is work done from TS, from T to S. So it's work done TS. Yeah, work done from T to S. So now I want to find work done TS. Okay, work done TS. Is a Q naught delta VST. Why TS become ST here? Because if you still remember the lecture video, this one have to invert because it's a final potential minus the initial potential. Which one is our final? Our final is Vs. Our final. So maybe make it smaller. Yeah, make it smaller. Our final is S. You understand? Our final is S. Our initial is T. So that's why we must use final potential minus the initial potential. Okay, final potential is Vs, initial potential is Vt. That's why we use Vs minus Vt. Vs minus Vt, that's why it become delta Vst. It invert from Ts. Okay, work done Ts is equal to Q naught delta Vst. Invert because we use final potential minus initial potential. S minus T. Alright? Okay, let's go back. Let's go back. We already have the, excuse me. Yeah, make it up. It should be good. Yeah? Now, so just now we already got delta Vst, isn't it? Delta Vst is positive 334 volt. So we can substitute into here. Okay? Substitute into here. Q naught, what is the Q naught? It is the negative test charge. The test charge has negative sign. We must put in the negative sign. Okay? We must put in the negative sign because, negative in scalar quantity is very important. The negative value is about the magnitude itself. It's not about direction. Okay? So now let's do our work. Okay? Then the test charge is negative. You must, for scalar quantity, the work done, if the charge is a negative, charge, you must put in the negative sign. Okay, because the negative sign means about magnitude for scalar quantity. Okay, so negative 1.5, negative 1.5, exponent negative 9, exponent negative 9. So we got the delta Vst just now, which is 334 volt. 334 volt. So I got the value is negative. What's the value? Yeah, 4.86 exponent negative 7 joule. So here the sign is a negative. Is it means direction to the left or downward? No, the negative in the work done is not about direction. It's about the magnitude itself. Okay, it's about the magnitude itself. Yeah, you must put the negative sign here. Okay, it's a scalar quantity. So what is actually means by the negative work done? Yeah, many questions. Yeah, many questions. Yeah. So what is really means by the negative sign in the work done? Many students will ask. If you look here, some teachers will say, yeah, and it is correct. This negative sign actually is work done by electric force. Work done by electric force. Another way of saying that, you can say that when work done, what is the meaning of work done? Work done is actually change in electric potential energy, isn't it? Electric potential energy is like the potential energy. A change of electric potential energy, or we can say final potential energy minus the initial potential energy. So when you have a negative work done, what does it mean? Negative means it is the final potential is smaller. Initial potential is bigger, isn't it? It's like small minus the big value. Small minus the big value. So we can say if small minus big, you get a negative value. It means what? It means loss in electric potential energy. So the negative sign here, it means loss in electric potential energy. That means we can say the final potential energy is lower than initial potential energy. From initial go to final, the potential energy drop. There is a decrease. We can say decrease in potential energy where of the test charge. There's a decrease in electric potential energy for the test charge when moving when the test charge move from T to S. T to S. The T is the initial, the S is the final point. And there is a loss in electric potential energy. There's a loss in electric potential energy for the test charge to move from T to S. Okay, there's a loss of electric or decrease in electric potential energy when moving from T to S. Okay, so the S has a the S has a lower potential energy compared to initial. Initial, which is the T, final is the S. Okay, there is a decrease in electric potential energy when moving from T to S. The S has a lower electric potential energy compared to the initial T. Right? So negative. Okay. In short, what I can say is when work done is positive, there is the potential energy increase. Potential energy increase from initial to final point. When work done is negative, the electric potential energy decrease when moving from initial to final point. All right, that's all for these questions. Let's move on to the next one.